Welcome to the course. So our today's topic is frequent item set generation in data warehousing and data mining subject. Myself Priyanka Gupta. I am working as an assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. I'll cover the topics today. Before coming to the frequent item set generation, we have to know about some of the important definitions. What are the different definitions related to the frequent item set is there. Then we will cover what is the definition of frequent item set, what are the different what is frequent item set actually, what is frequent set and item set. Then we will see their example, some examples we'll see, and then we'll go to the applications of frequent item sets. What are the examples are there, we'll see in real time one. Then what are the different frequent item set rules are there, so we will see one by one. Let us start. So before going to the frequent item sets, some of the important definitions are there, like there will be the one term support. There will be the one term support. So what is basically support is, it is one of the measure of interestingness, right? This tells about usefulness and what are the certainty of rules are there in the formula, in the word, in the basket. So if there is an example, if suppose 5% of support is there, right? If 5% support are there in some example, so it means total of the 5% of the transactions is there in that transaction for the data set, that is follow the rule. So there is a formula to calculate the support. So if there is, if support A depends on B, if support A depends on B, the support count A union B. So there will be the support count A union B, right? So we can imagine there is a range between 0 to 1, either 0 or 1. So in between, the all the sets will be there in the database set, right? So given a rule A to B, here the A stands for antecedent. A is the antecedent and B is the consequent, right? So in this formula, what are the different terms are there, I'll tell one by one, right? So the support metric, there is a support metric that is defined for item sets, that is defined for item sets, so not for the association rules. So in some of the other examples in earlier class, we have seen there are some association rules written over there, right? So that frequent item set generation is not related to the association rules what we have written earlier, but that is basically related to the item sets. If some of the item sets are there in one transaction, if there is a frequency, the items are suddenly they are frequent in nature, there are duplicacy of items, then the frequent item sets generation will occur, right? So the table produced by the association rule, that mining algorithm, contains three of the frequent support matrix, three of the different support matrix. So what are they? The first is antecedent support. The first is antecedent support. The second is consequent support, and third is simply support. So there will be the three types of support matrix that will occur in the formula. So we should know about what are the different terms. So the first is antecedent support, second is consequent support, and third is simply support. So what we are deriving from here in this formula, that support A stands to be the support count A union B. So the support count we will count as A union B. So in A union B, what will we will get the items that will be the support of A that depends on B. So that was the understanding about if there will be a item set in a database. So what are the different consequences are there? How what is support? Why we are going to analyze support? So what are the other dependent terms are there, and what are the consequences between them? So here we have seen like antecedent support. So that computes the proportion of transactions. So that is nothing but the proportion of transactions that contain the antecedent A, that, and consequent support computes the support for the item set of the consequent C. So here we have taken B. So we will write it as a B, consequent B. So here, what do we mean by antecedent support and consequent support? The antecedent support is nothing but that is a proportion of transactions that contains the antecedent A. That contains antecedent A. And consequent support is nothing but that computes the support for the item set of consequent B. So there were support terms also in the support metric. So support metric then computes the support of the combined item set. So that occurs in A union B. That is nothing. C is nothing but that we should call as a B in the item set. So the support will be the combinations of that is going to compute the support of the combined item set that is occurring either in A item set, either in B item set. So there will be the union of that. If that is occurring in both of the item set, then that will be the support, right? So here we can see the support that is going to denote antecedent support, consequent support, and via the both will be depend on the minimum of antecedent support and consequent support. So that will be calculated as minimum of antecedent support and consequent support. Typically we can say the support is used to measure the abundance of frequency. If there is a more frequency in one item set of any database, so there will be the support is going to occur. So it is why we are using the support when there will be the more frequency of item sets that is occurring together. So some of the time we can say it as a significance, we can say it as a importance of that item set. So that will be the importance and significance, or we can say support of that item set for that database. So that related database, the support we are going to be dependent on antecedent support and consequent support. And how we are going to measure that? That will be the union of the items divided by items that is in the item set A. So as we have seen in the first slide, right? So that was nothing but the support count A union B. So directly we can check the support for A that depends on B. So usually we are going to refer the item set that is a frequent item set. If we are going to tell an item set that is frequent, so what we have to do? We have to we have to check the if support is larger than the specified minimum support, that is threshold. So we will as we can say data warehouse manager, and who are going to check who are going to make these rules for that. So they have to check the minimum, they have to set some of the minimum support threshold. Then according to that, we are going to check our support, what we have find from the that item set. So that will be that should be the larger than that support, that threshold support. So due to this downward, so basically if that types of item generations rules will occur, that will come into the nature in downward closure property. So in that, what is downward closure property? In that, all of the subsets of a frequent item sets will also be the frequent item sets, will be the frequent set, will be the frequent item. So if there is a subset of that frequent item set, that will also be the frequent in nature. So that is the downward closure property of that frequent item set generation. So here we have completed what is support. So now the term comes, what is confidence? What is confidence? So confidence is nothing but if we are going to suppose check the confidence of 60%, if there is from formula, if we get the confidence as a 60%, so that means the 60% of the customers that is going to purchase a milk and a combination of bread, all they're going to bought together. So that in the formula we can see the confidence A depends on B. So the formula will be support count of A union B divided by support count A. So what is the support count is for A item set? That will be the confidence of A depends B will be the support count both if the item is occurring in both of the item sets, divided by the item is occurring in the first item set, that is A. So the range will be for that 0 to 1. 0 to 1. So the confidence of a rule A depends B is the probability. It is the probability of seeing the consequent of any transactions, given that it also contains the antecedent. So that is nothing but when we are going to measure the probability that if there is a consequent in the transaction, there will be the antecedent there in the item set. So for support, we need to have all the items that is frequent in that item set and what is there in the first item set. So we will divide by that and we will get the confidence of that item set. So here we can we have to check if the metric is not the symmetric. If that metric, the support, that confidence metric is not symmetric or not directed. So for example, if the confidence of A depends B is different than the confidence is B depends A. So if there the metric, the confidence is not symmetric and undirected, directed, so there will be the confidence that the confidence of A depends B will be different to the B depends A in that condition. So in the second condition, if confidence is 1, that is maximum. So for a rule A depends B, so if the consequent and antecedent is there, that will occur together. That is going to occur together. So if confidence is 100%, we are sure the items are there. That is A in B, and that is divided by item sets in A. So what if confidence is 100%? That is maximum of that. So if A depends B will be there, so antecedent and decedent consequent will also be there in the rule. The third rule is if a rule satisfy for both of the minimum support, I am telling for support also and for confidence also. So if both the rules will satisfy as a minimum support and minimum confidence, so that rule will be the strong rule. That the rule will be called as a strong rule, right? So here we have seen the term support count. So what is support count of any item set, any item? So that is nothing but the number of transactions in which X appears. X is going to appear. X item set will be there. X type of item set will be there in that set. So if X is a union B, then if there is a frequent item set in both of the item sets A and B, right? So then it is the number of transactions in which A and B both will be there in the item set, that will be present in the item set. So here we have understood about, we have used the term support count. So the support count is nothing but that is if there is a number of transactions that is occurring for any item set X. So the if X will be the A union B, suppose we are writing A union B, that tells the both of the item set items is occurring together in both of the item set. So there will be the number of transactions in which the one item set is there in one set and other is also there in the set. So the third, here we have completed confidence. The terms lift also comes together in when the support and confidence will be there. So what is lift? Basically the lift, we can say interest value. Interest is the second word for that. So that is nothing but that is a association rule, that is a ratio of confidence of the rule and the expected confidence of the rule, right? So that will be divided by the expected confidence of the rule. So the expected confidence of a rule is nothing but that is a product of the support value. That is nothing but here will be the production. What is, we have to multiply the both of the support values here. So that is nothing but that will be the support value multiplication for the rule body and the rule head divided by the support of the rule body. So in the formula we can see here the lift A depends B, that is nothing but the support count A union B divided by N. I'll tell about what is N here. Support count A, that is the first item set, divided by N into the support count B of B. Support count of B. So here the N is nothing but that is the number of transactions. So the lift we will calculate as support count A union B divided by N, number of transactions, divided by support count A divided by N into support count B. So the N will be divided by both of these A and B together. So the confidence value that will be defined as a ratio or support that is joined the rule body and rule head divided by the support of the rule body. So here in this formula we have seen that this term. So what is that? The support count of the A body, B body divided by number of transactions, and that will be the in above formula, that support of count of A union B divided by number of transactions. So here N was the number of transactions that is occurring for that transactional data set database. Support of A union B, that is nothing but the number of transactions that is occurring for A and B both of the item sets. The support of A, that is nothing but the number of transactions for A. Support of B is nothing but the number of transactions for B. Right? So here the next term comes as maximal item set. So here, what is maximum item set? So the item set that is maximal frequent. So that is frequently occurring at maximum for the item sets. So if that is maximum as a because in any item set, if most of the items are frequent, out of 5 4 are frequent, out of 5 are frequent, so that will we will call as a maximal item set. So if none of the its supersets are frequent, so if we will calculate the superset that is not frequent but the items are there in as frequent in the item set, so that we will call as a maximal item set, right? Next term comes as a closed item set. So an item set that is closed if none of its immediate supersets have same support count as well as same as item set. So the support count, what is the support count for the superset? That is as same as the item set. There is that will not be matched, then there will be the closed item set generation. So the rule tells that if the item set is closed when there is superset is not having the same support count as the item set support count, right? What is K item set basically? K, X, anything we can say. Item set basically. So the items which contains K items, which contains any number of items. So that is nothing but the K item set. So it can be said that an interest the item set is frequent if the corresponding support count is greater than the minimum support count. So if we have set the minimum support count because in to calculating any to generating any type of frequent item set, we have to set a minimum support count for the whole of the item set. So if that the support the item will be frequent in nature and the support will be greater than the minimum support count what we have set, so there will be the possibility that is the frequent item set of K item set. Frequent item set of K item set, right? So if a set of item that is going to appear in the many baskets, if there is a set of items that is going to appear in any many baskets, many of the transactions, so that will be called as a frequent. So that is a definition of what is frequent. The given example that a set of items and a given minimum frequency. So any set of items that is going to occur at least in the minimum number of examples is a frequent item set. So if there is a possibility in the two of the item sets, if suppose if the frequency minimum frequency is there to matching what are the frequent item set, so that item that will be the frequent item set for the whole of the items. So for example, if we will take an example for that, if there is a customer of an online bookstore, so that could be the considered examples for to understand what is a frequent item set. So there is a online bookstore for the customers, right? So each is representing the set of books, whether the customer is going to purchase, right? So there will be the possibility, there will be the books and set of books the customer is going to purchase. So for example, a set of books we can check for if there is a list. There is a book machine learning, there is a book the elements of statistical learning, and third book is pattern classification. So in this item set there are 3 books, right? So that is a frequent item set if it has been bought by the sufficiently many customers. So for the each transactions that is purchased by many customers, so we will check the occurrence. If the possibility the machine learning book is occurred frequently, so that will be the frequent item set for that item set. So that will be the frequent in nature for that database, right? So we understood about what is the frequent item set for the online bookstore. If there is 3 books, so if some other customers is going to purchase the same book, so that will be the frequent in nature. So we will call as that item set as a frequent item set. So given a frequency threshold, we can say only 0.1 or we can say 0.01% will be for online store, because all the set of books that have been bought by at least that many customers will be called as a frequent. So that I have said in another way. So there will be the possibility that 0.1% customers, 0.01 point customers is going to purchase the books as a frequent item set. They are going to purchase at least same book as a the same book frequently. So the discovery of all the frequent item set is a typical data mining algorithm, typical data mining task. So before going to the data mining, we should know about what are the different rules are there. So we are checking the frequent item set generation rule for the transactions for the database. So we have to, if we are going to check the frequent item set, we will know about the what are the frequency of purchasing the item, particular item. So we can the analyst, they can have the better knowledge, better understanding, so they can have the better business process, better sales in the business. So by that is important terms to understand about frequent item set. So the original use of this rule, this type of rule has been when we are going to generate the association rules. So before going to the association rules, we should know about the frequent item set generations. What are the rules to generate frequent item set? So there should have some knowledge. Then we will be able to understand how we are going to set the association rules for that data set. So for this this type of frequency, that type of rule generation, there is a particular algorithms are there to understand about that. So some of the association rules algorithms are there. So a priori is the most classical algorithm is there. So for that we can have the frequent item sets. So that was the we have seen the better understanding what are the frequent item set, how we're going to count that, how they are going to occur for the any transactions, any of the we can say basket. So how they are occurring, what are the nature, what are the different terms we are going to calculate for that, to understand how the association of the one or two items is occurring together, are there in the basket, there in the transactions. So for that we will use the a priori algorithm for better understanding. So I'm going to be formal, that if we assume there is a number that is S, so the S is nothing but that is a support threshold. So if we are writing S is equal to something 2, so that will be the support threshold. So that we will calculate in the terms of percentage. So 2 will be the 20%. Support will be the 20% for that transaction. If that S is there, so that is nothing. S is equal to 2 is nothing but the support count. So we are going to calculate the support count as well as the support in the terms of support threshold. We have to set the minimum threshold. So that was the formal introduction about S. What is the term S? If you are going to write the term S as a support threshold, that will be the support threshold. If there is a I is a set of item, so the support for I will be the number of baskets, number of transactions for which the I will be the subset, right? So we will have the we are having the some introductory knowledge of the mathematics. So we can have that terms, we can have these, because we should know the probability terms before we are calculating the support and anything related to the data mining, data warehousing subject. So before going to that, we should have that terms, understanding what is the subset, what is set. So we should have what is a superset. So if as I is there as a set of items, so there will be the support. So that support is nothing but support for I is number of transactions, for which I will be the super subset. I will be the subset for that set of items. So we can say the I is frequent. If when it is frequent, what I have said, the support, when the support as what we have set as a, if we have set support as a 50%, so the if the s if we are calculating the support, if we are calculating support for one basket, one transaction, so if the support will come after the calculating the from the transaction, so if the support is 60%, so that will be the, that is more than the this support. So 50 is more, 50 is less, 50 is 50 is more than 60 is more than the 50. So that will be the support is more. So there will be the possibility, there is a sure possibility the items are there as frequent in nature, that is occurring in for that transaction. So for example, if we'll take an example, if there are set of words, if there is set of words, there are some words, so each set is a basket, each set is a basket, and the words will be the item for that basket. So, right? So if there is a basket, right, if there is a basket, so there will be the set of words, and what the set of words, the words will be there for the as a item, we will count at the item. So if we took sets by googling cat dog and taking the snippets from highest ranked page, so that is an example basically. So we don't have to concern about if the some of the words is going to appear twice in the basket. If there is a possibility the same word there is occurring together twicely, thricely, so the basket will be the set for that, and in principle the item can appear only once. So for that one basket, the item should be occur one time. So so that is a rule for one basket. But also the we have to ignore the capitalization. So if we are writing also, if we are having the set of item, set of rules, set of words, so that will not in the capital letter. So for one basket, in one basket the item should be unique, the item should be the simply unique. So item will not occur twicely, thricely. So that will be applicable for the one basket. But for the another basket, if they are matching, that will be the frequent items. So here in this example, in this figure, we can see here are the 8 bags, here are the 8 baskets. So each one of them that is having the items, that is nothing but the words. So in this basket there is a cat and dog and bites. So these are the 3 items that is there in the first basket. In the second basket, there is a Yahoo word news claims a cat mated with a dog and produced viable offspring. So offspring. So these are the words that is occurring in the second basket. Like that, there are so many words in the these are 8 baskets. These 8 baskets, there are some of the words are there. So we will check what are the rules are there for these each of the baskets, and how we are going to denote as rules. So since the empty set is a subset of any set, so if there is a set and the subset is empty, the subset is having nothing, so that will be the empty set for that. So the support will be for that. Support for all the all of the set will be the 8. All support will be the 8 for that example. So among the so we will check for the single sets. What are the single words are there? So we will check if there is a possibility, there is a frequent items in the example. So here in the example we will check if for suppose for the first basket, if we will check if there is a possibility the cat, dog and bites are there in other bags. So here the cat, dogs and bites in there in the first. Here is also the cat word, dog is also there. Okay. Here in the third basket, cat is there, dog is also there. Bite is not there in any 3 of the baskets. In the fourth basket, dog is there, cat is not there. But in the fifth basket, cat is there, not dog. In the fifth, sixth, cat and dog both are there, but not dog is occurring 2 of the times. 2 of the times. So that cannot be the list for us. So in the other 7th, dog and cat are there. In the 8th, the dog and cat is not there. So like that, we have to check for each of the baskets. So the support of all of the sets will be the 8 times the dog is occurring. So the support count, the count will be for that 8. The support count will be for 8. So among the single words that is matching, so the cat and dogs are matching frequently in the other baskets, from the other baskets. So dog is appearing in all the baskets for the 5 times. But so its support will be the 7. Support will be the 7. So that the support will be the, while we have to check it from the minimum support is there or not. So the support will be the 7. How it comes? The dog is occurring 5 times, but the support count that we have to calculate as A union B. A union, that is occurring in both A and B item set. So the support will be for that is 7. While the cat is going to occur for 4, that appears in all but 4 and 8. So their support will be, if we are going to calculate, so support will be the 6 for that. S is equal to 6. For the dog, the S is equal to 7. That is for dog. That is for cat. For all the baskets. As like same, the word and. The and is there, so that is also the frequently occurring word. So it is occurring in first item set as well as in second, right? So in that is also in 5 basket, 7th and 8th basket. So that will be the support will be the 5. 1, 2, 3, 4, 5, right? So the support will be for support count will be there. How many items are there in the baskets? That much count we will take as a support. In the other basket, what we have seen, 7 times. The cat that is appearing in the all of the baskets, that is having the 4 and 8. The support we will counting as 6. So the words A and training, that is going to appear in 3 sets. 3 of the set that is occurring in the 3 of the sets. So while for and each is appearing in the 2 of the sets, 2 of the baskets. So no other words are going to appear more than once. So these were the words that is frequently occurring for these are the 8 baskets. So we have completed that example. So now we will see about what are the different applications of frequent item sets. So the original application of the market basket model was for the true market basket analysis. So that has been created, that has been adopted for the supermarket examples. We can say the chain store, different retail chains are there. So they record the content of every market basket. So there are the physical shopping malls, there are cards. So they have to be they have to be checked the each of the we can say cart that is going to bought from the one customer. So they need to check it as a physically. So they are going, if they are going to have that calculation, they have to go for each of the customer who have purchased same of the items. They have to compare the each of the transactions. So here we can say the items are the different products that are that the store going to sell, and the basket that is having the set of items. So in a single transaction, in a single purchasing for the one transaction. So for the finding frequent item set, a retailer can learn what is the commonly bought together items. So especially important, that is going to be pair. What are the pair of sets the customer is going to purchase? So two or three other customers is going to purchase. So if that is more frequently is occurring, that is expected, that is the item will going to be bought together. If that is not, that item is going to be bought independently. So the famous example of unlikely, we can say for that the diaper and beer example is there. So one for the diaper and beer example, if we can associate as that if the theory is there, if the person, if the customer, he is going to purchase diaper, then he is probably is having the baby at home. The consequence is that if he have the small baby, young baby at home, then only he is going to buy the diaper. And if he have a bad baby, he is not going to purchase the purchase the beer at directly at the bar. So here he can purchase the beer if he or she can have baby, but they can have they can purchase if they are having the baby, he or she can drink that beer at a home, because they cannot go outside. So that is more likely to bring the beer at home. That is the consequence for the diaper and beer example. So one would hardly expect those two items to be related. That is not related, but through the data for this example, the data analysts have done analysis. For that, the one chain store that they have got that association or relation, that if the people who buy the diaper, they are usually likely going to buy the beer for that transaction. So that was the frequent item set. Some other examples are also there, that in the first example, if we can see, the baskets of document is there. So in the basket of documents, there can have the web pages, blogs, tweets. So the basket of, we can say, document is containing the items, they're containing the words that is going to present in that document. So that is nothing but the if the we have to check the frequency of each of the words, if each of the items, we have to check the document, each of the document. So the basket of document will be there, we have to check each of the document. If the words are occurring in each of the other document, so that will be the frequent items, that frequent words. So if we look a set of words that appear together in many document, the set will be dominated by the common words, that will be the stop words. So if there will be the common words, that will be the frequent words they are occurring in the document, other document. Second example is, best example is plagiarism. Plagiarism is nothing but the, if there will be the some common content will be there in the document, if the document is there in the database, so that will be the plagiarized, that will be the, we can say, that will be the plagiarized document. There is a consequence that the document is needed to have the other words, other paragraph. So we have to change that paragraph. So if there is a document the item is there, will be the document, and the basket will be there, sentences will be there as a basket for that plagiarism. So an item and document is in basket a sentence if there is a sentence in that document. So for that plagiarism, we can understand these of the two terms as this. So if we look and we can find such of the pairs of items is there in what the document we are going to check for plagiarism. So that is if they are going to be occur in several other baskets. So then we have the two documents that share the several sentences as common. So if even one or two sentences are there as common, so that will be the plagiarized word sentence. So we have to change that sentence from that simple as a simple sentence. So the third example is biomarkers. So if the item that is of two types, that is biomarkers, such as genes and blood proteins. Second is diseases. So the item is of two types, that is blood protein and disease. So each of the basket is the set of data that is about the one patient, so their genome structure. So their genome structure, we can say the blood chemistry findings and analysis, that will be the medical history of the disease. So that we can have as in the form of the medical history of the patient for that disease. So there will be the frequent item set if that disease is commonly occurring for the other patient. So the frequent item set that is containing one disease and one of more biomarkers suggests a test for the disease. So if there is a possibility they are matching, so he or she patient will go for the testing of the disease. So in here we will see the normal terms about the frequent item set. What are the basic terms for the frequent item sets? So in frequent mining, usually the interesting association and correlation between the item set in that will occur for the relational as well for the transactional database that is going to be found. So in short, we can say the frequent mining that is going to show the each of the items that is appearing together for a transaction or relation. So that will be the frequent mining for that particular transaction. So the frequent item set is a generation of association rules from a transactional data set. So whether we are going to search for the mine for the frequent item set, for that we have we have to write the association rules for that. So that was the understanding of the introduction of the frequent item set. What are the rules are there? What are the different consequences are there while we are going to check the frequent item set for the transaction. So we are going to generate frequent such rules for the association rules for the data mining for that transactional data set. So if we can say, if there are two items X and Y is there, that is going to be purchased together, but frequently. So then it's good to put them together. We are going to put them together in a store for providing the customer as a offer, as a discount, because the customer, he or she is going to purchase that item for sure. So we should have the item store, supermarkets, persons, people, managers, they should have give some discount. They should have some common purchasing offers. So for that, the customer is most likely is going to purchase the both of the items together. So if there will be the if they are going to purchase the one item, if there will be the possibility there is just some discount, we can say some offers are there, so surely he is going to buy the another item with that item. So this can relatively increasing the sales, that is going to increasing the sales of the that supermarket store, right? So for example, if we can have one example. If a customer, if a customer is going to one supermarket, a simple shop, so if he's going to buy a milk, he's going for to take milk packet. So milk packet, if there is a possibility, if the bread is bread, if the person is going to purchase milk, if the bread is there together, kept there, and there is some discount, if he or she will purchase the milk, he will get discount of that amount. If he will purchase the butter, he'll purchase the butter, so surely he'll think about that. He's going to purchase the bread all together with the milk. Another example, if there is butter also in that kept their almirah butter, so most likely he is going to purchase butter also. If there is a chance, he is getting the some of the possible discount, or some of the offers are there. So that will be the frequent combination. The customer, he is going to purchase the milk and bread and butter and so other things together, jam and all, he's going to purchase together. So the seller, the we can say the shop seller, we can say the supermarket seller, he or she can suggest the customer, he can tell the customer verbally. So if you will purchase this item, you are getting this item as free item, as some of the discount are there. So the customer is going to purchase the item for sure if they are getting the discount offer for that. So most likely the sales will be increasing for that. So that was all about the frequent item set generations before the association rules mining. So what are the different consequences are there for to generate frequent item set? What are the different rules are there? What are the different formulas are there to calculating what is the consequence we are going to purchase some of the frequent items together? So that was all about the frequent item set generation for the today's session. Thank you for watching. We will meet for the next in the association rule mining generation class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.